squared minus 18a. So let's see if we can factor. Remember, when we're factoring, we always look for a greatest common factor, which can be numbers and variables. So I know that 2 will divide into both 14 and 18, and also I can divide out 1a. So that's my factor that will come out front, and then once I divide those out, I have 7a minus 9 left. Now when you have two things multiplying together to equal 0, you can use the zero product property rule and set both of them equal to 0 and solve. So now we divide by 2, so a equals 0. Add your 9 and divide by 7, so a also equals 9/7. In B, we've got x squared minus 169. Now, if you look at those sections on review factoring, we know that this is a difference of squares. This is x that's being squared minus 13 that's being squared. So I'm thinking this is as of a positive 169 right now. So that will factor as the first term, or x plus our second, which is 13, times the first term, which is x, minus the second, which is 13. Then we use that zero product property rule again, set them both equal to 0, and solve. So x equals negative 13, and x equals positive 13. This is another problem reviewing concepts 41 and 42. So the path of a rocket launched upward from a height of 64 feet is represented by that equation, where t is the time in seconds compared to s of t, which is the feet above ground that the rocket is. At what values of t will the height of the rocket be 0 feet above ground? So that means we're going to replace s of t with 0. And then we'll just use our factoring methods to solve for t and find out those values. So negative 16 can divide into each of those terms. So if we factor that out, we get t squared minus 3t minus 4. Then to solve, we can divide both sides by negative 16. So 0 equals 2t squared minus 3t minus 4. So let's see if we can factor two numbers that will multiply to give us negative 4 and combine to give us negative 3. If we use the star method, then we'll put a 1t here and a 1t there. So I think of factors of 4, 1 and 4 up. And if I make the 4 negative, then when I combine them, I get negative 3. So this expression will factor as t plus 1 times t minus 4. Now we've got two values equaling 0, so we can set each of them equal to 0 and solve. So t plus 1 equals 0, and t minus 4 equals 0. So subtract the 1, t equals negative 1, and t equals 4. So those are the values. If we talk about what makes sense, the one that makes sense is 4, because that is in terms of seconds. We get a negative 1 because the rocket doesn't actually start on the ground. It starts up in the air. So we don't have a time where it's on the ground two places, just one. Now lastly, we've got 3 graphs of quadratics in number 9. How many solutions are there for each quadratic function graph? Remember that a solution is an x-intercept. So on graph, let's just write that. Solutions are x-intercepts. So on A, we've got 2 x-intercepts. So our solutions, there are 2. Let's go ahead and name them. So x equals negative 3 and x equals positive 4. Well, now in B, graph B, locate the, there we go, locate the x-axis and notice that you've got one place where the graph is crossing. So that is one solution. So we have one solution, and let's name it x equals positive 1. And then finally, there are no real solutions in this one, so we'll just say that, no real solutions. Now look at the rest of your packet. Go through the list of the concepts that we have there for you. These are the newest concepts that you've learned. Decide on any of those that you want to review, and then watch the final video that's after this one in the playlist, and then you'll be ready to take your final spiral and final exam for Algebra 1. Good luck.